Test run, using manipulatives for the difference of squares. Okay, should I use your name or not?
Sure.
Okay, Shannon, this thing in all orange, if you look at it from the top, what's the area?
Well, you have 3 by 3, but minus 1, so you have 8.
Okay, so you have 8, 3 by 3, or with what we'll be talking to them about, in the actual session late next week, 3 squared minus 1 squared. Okay, can you rearrange that? Still keeping that as 8, but make it a rectangle. Okay, so nothing added, nothing lost, just moved around. What are the dimensions?
4 by 2.
4 by 2. I think they'll know the phrase dimensions when they talk about area.
I think so.
That's what I figured. Okay, so what's the relation of the 4 and the 2 to that 3 squared minus 1 squared you were talking about?
Are you saying the 4 squared minus 2 squared, kind of like the 3 squared minus 1 squared?
We had 3 squared minus 1 squared to get that area of 8. And this still has an area of 8. You said the dimensions are 4 by 2. How are 4 and 2?
They're double. 2 and 4. 4 is a double of 2.
But instead of looking at it that way, how are they related to the 3 and the 1?
They're just one step higher. So 3 goes up to 4 and 1 goes up to 2. Is that what you're going for?
Not quite, but let's try looking at this one. We can come back.
Okay.
All right, so what's the area there, if we're just looking at the top of that?
Well, you got 5 by 5, and then you're missing 4, so 21.
Okay, we have an area of 21, 5 squared minus 2 squared, and rearrange that the same way, that you get a rectangle. Okay, and what are the dimensions now?
That's 7 by 3.
Okay. Mr. MLC Director, could you take over the filming? Write some stuff over on the board. That's what we're going to do. Face it towards the board.
Board, okay.
Okay.
I'm not playing the role.
You said the dimensions were 7 by 3 when you were rearranging, right? Okay. So we're looking for a connection between the 3 and the 1 to the 4 and the 2. We're not talking like, we're talking about that pair and this pair instead of this to this and this to this. So this is a pair to this pair. And similarly, this pair of 5 and 2 in connection to that pair. So put that way. Does that give you an idea?
That pair to that pair. Well, my brain's thinking of that 5 and 2 together to 7 and 3 of the 1 to the 4. I don't know if that's what you're trying to deduce here. Is that? Well, let's go. 5 minus 2 is 3. 3 minus 1 on the other side is 2.
Okay.
And then the 3 plus 1 is equal to 4.
You just discovered the difference of squares.
Let's go.
All right. I'll come back tomorrow when you've got some more time. We'll discuss the difference of cubes and the earlier stuff in this section. All right. Thank you, Mr. MLC Director, who I have not found out whether you want your name used or not, so.
Well, the camera work is not going to be very good.
I didn't realize that's what you were.
I have a stabilizer. Did you have? So when we were looking at the difference of squares there, that's the first example, not the second example, but the first one would be connected to the formula for a geometric sum, where there were just two things being added. So when we had the thing with an area of, what was it?
There was an 8 and a 21.
Okay, so the 8, we got that from 3 squared minus 1 squared. The next one and that one, you could have 1 plus 3 plus 9. And I actually have that one right here. So here's how I'm going to try phrasing this. Taking a look at this pair here, I'm not looking just for the volume, but to express that based on the layers there as things being added up and expressing those as powers. So do you think you can do that for that one?
So you're saying like.
So we've got 1 plus,
And then you go to 2 and then 4.
okay, express,
But like
so,
in powers.
yeah.
Okay. 1 and then got 2 to the first power, and then you could do 2 squared. Is
Yep.
that what you're looking for?
Yep. Okay, if you could hold this a moment. Guess I would need to be down here, right?
Right.
We've got 1 plus 2 squared, or 1 plus 2 plus 4, which is giving us 7. All right. Okay, so now let's take a look at the solid blue one there. And we're not looking at the layers anymore. We're looking at that in the same way that we're looking at the thing taken away. So overall, before that one spot got taken away, what's our volume?
You have the 7. Wait, 2 times 2 times 2 is, yep, 7.
Okay, so 2 cubed, giving us 8,
Minus 1.
taking away the 1. Okay, I'll have you hold that again. And actually, we can express the 1 as 1 cubed.
Yep.
In that case, we're getting exactly the same thing. Okay. All right. So let's take a look at the next pair. That one I already gave away. That would be 1 plus 3 plus 9, or 1 plus 3 plus 3 squared. Okay. And same kind of thing there. We've got a cube with a volume of how much before you take away the,
The 27.
okay.
But then you take away 1. So 26.
Okay, so here we had 1 plus 3 squared, i.e. 1 plus 3 plus 9 for a total of 13, right?
Mm-hmm.
Okay. And the 27, express that using a power.
3 cubed.
Okay, so 3 cubed minus 1 cubed. It's going to give us 27 minus 1, which is 26. And is there another color here? Yes, there is. Here, let's use one that's very close to purple that probably won't show up as very different.
Right.
But 7 and 7 being exactly the same. 13 and 26 not the same. But we're going to take a look at one more pair here. I guess I'll have enough room to put it on here. Sort of, kind of. All right. So again, expressing the volume of this one similar to what we did right here and right here.
Oh gosh, 4 by 4 is 16 by 3. Lord.
There is 16 at the bottom.
21.
4.
21.
Okay. So expressing that this way,
Mm-hmm.
how would we do that?
Do you want the 4 squared?
That would be the last one.
Uh-huh.
So 1 plus 4 plus 4,
4
squared
squared.
for a total of 21. Okay. And then that one. Okay, so we're
times 4 times 4 is 64, so then 63. Right? Did I do my math right there?
Mm-hmm.
Cool.
okay. We can hold that again. All right, so we've got 4 cubed minus 1 cubed.
Uh-huh.
64 minus 1, 63. All right.
Mm.
So this pair
Stayed the same.
got exactly the same.
Mm-hmm.
How are 13 and 26 connected?
Doubled.
Okay. 13 times 2 would get us 26.
Mm-hmm.
Okay.
Mm.
And we're going to look at one more here in a moment.
Mm-hmm.
But similar to how with the difference of squares, well, I'll hold off a moment.
Mm-hmm.
Does 21 go into 63?
It's tripled.
Okay, 21 times 3, giving us 63. Okay. Just like with the difference of squares, we're looking to write this as a product of two things.
Mm-hmm.
The fact that this stayed the same,
Uh-huh.
we could say that we'd multiply it by 1.
Mm-hmm.
Any idea why, when the common ratio that we would multiply, in that first example, that was 2,
Mm-hmm.
that we're multiplying by 1 here. Here our common ratio is 3,
Mm-hmm.
we're multiplying by 2. And our common ratio here is 4, we're multiplying by 3.
Yeah. N minus 1.
Okay, so it's 1 less than what that common ratio is.
Right.
So formulaically, what we're getting is, not that we'll express it this way with them,
Right.
probably be something expressed in words, but the geometric sum part that we're looking for here, this part,
Mm-hmm.
you're multiplying by 1 less than the ratio, and we're getting x cubed minus 1 cubed, or just x cubed minus 1. You could actually generalize that to a difference of 2 cubes formula, but
Mm-hmm.
we're just concerned with then turning that into, we'll be letting them know that that's what we're focused on.
Mm-hmm.
So just like x plus 1 would be x squared minus 1 over x minus 1. As long as you're not using a ratio of 1. If your ratio is 1, you're just getting a constant sequence, not
Yeah.
a geometric sequence. And also you would be dividing by 0. But you're getting a formula here for the geometric sums with 2 terms, with 3 terms.
Mm-hmm.
we wouldn't be able to talk about 4 terms with this kind of presentation, because then you'd have to be able to make something 4-dimensional.
Right.
But maybe they could express in words, well, if we have this many terms to add up, where we keep getting the next term was multiplied by some common ratio, that number of terms is shown up here. So you've got the power, you take that common ratio, based on how many terms there are, minus 1, all over the common ratio minus 1. See if they can get that, but even if not, even if we only get so far, maybe the first 2 things will take quite a while anyway.
Mm-hmm.
But that's the plan for the geometric sums.